Alright, how's it going everyone? Welcome. Euler Gonzalez here again, and today we're gonna take a look and solve this particular problem called panagram or pangram. Check if the sentence is panagram, pangram, my bad. So this is also part of the series of videos and problems that we're gonna solve as we move through this code or this roadmap provided by LeetCode, in this case NeetCode, uh, which was made by Navdeep Singh. He is now a software engineer that has previously worked at uh, Amazon as well as software engineer at Google. So he built this series of videos as a way to now uh, provide is a roadmap. What are the essential tools and patterns that we need to learn as we move on to solve specific common problems? Why is this, you might wonder, if you want to know a little bit more about the in-depth of this, especially from the business aspect. So you are actually learning all of these things as a way to solve more complex problems for people with money. Pretty basically, you know, it's like, and as you learn all of these techniques, you're gonna learn is now not only what are the problems that those people are facing, okay, which is quite interesting, I must say, but also along the way, it invites you to decide if that is the kind of problem that you want to include in your life, or that you want is to find some other problems, or you want to solve your own particular problems. But the TLDR of all of this is that by looking now at this particularly tools, data structures, algorithm, and problem solving techniques, all right, a lot of the time that's the best way to find your solution. And especially if you're in an interview, and not only in an interview, because the idea here is to also look at how you can reuse all of these tools for your daily life. Uh, that is the entire reason of this series of videos. So, because the methodology here is using JavaScript primarily as a way to solve that, all right? So by sticking to this particular language, the ECMAScript, and then we can switch to any other programming language. So, for example, Python. The whole point of this is that the syntax doesn't matter. What really matters here is that how you communicate your thoughts to solve a common problem using these particular tools as a way to come up and solve that, right? So this is a roadmap that was made by Nadeep. Nadeep. Uh, we start with arrays and hashing, two pointer and the stack, followed by the sliding window. And so far we are actually at this point, right? Sorry. So on the arrays and hashing, two pointer, stack, and sliding window, the the two, on today's video we're gonna see now is more about arrays and hashing as to a common exercise as a way to now get into a particular job. That's the idea here of today's video. And well, the methodology here is that we're gonna take the 45 minutes, where now the first thing is to describe what we have done so far, provide the value proposition of each one of those problems, as well as what is the techniques, what was the data structure, the algorithm, and the technique that we use. All right. And then finally use 20 minutes to understand the problem and see how we can solve that. All right. And if we are not able to find a solution, no problem, because we're gonna take a look now at the solution. But the idea here is to actually use all of these tools, data structure, algorithm, and problem solving technique as a way to see how can I come up with a solution based on this particular problem. So over the couple days here, as you can see right now, has been like 15 day, no, 12 day. The idea here is to solve this particular problems, uh, but as a way to now recap and understand what was the value proposition of each one of them. For example, in the contains duplicate, we use this now a set as a way to identify now if this collection of values contain any duplicate numbers. We're going is to actually is return true or false. So the idea here is to understand how you can use, for example, this particular data structure called set, right? Similar to the valid anagram, where an anagram is a word that, yeah, an anagram is a word that when you read forward and backwards is the same. So the idea here is was first understand how you can now is use strings, how you can is use the built-in method specifically for ECMAScript, right? As a way to now, because at the end of the day we want is to see if two words actually is a valid anagram. So the idea here is to, by putting all of them into a lowercase, okay, and then let now transform each one of those strings into an array. Use the built-in method called sort that actually is going to compare each one of those elements. Yeah, that is going to compare each one of or is going to rearrange all of these elements for us, all right, in an alphabetic order, in an ascending or descending, starting from A to C or C to A, all right. And then if we check at least one of them, and then we reverse that, we're going to compare if that actually is the same using is a particularly built-in object called object.is. That is very technical detail. Sorry. Yes. So there is a very technical detail behind that. uh, and this is the way how you can actually validate is the anagram. The two sum, the idea here is to see how you can now by using is understanding how you can work with an array and a hash map as a way to use hash maps for counting, grouping, or compare. That's how we come out here with a solution like this. And there are also some reflection here, like what information you want to store in your hash map. So what data your hash map will represent. And this is when you started to build up this foundation of data representation. With group anagram, it was also quite interesting because here we use now a hash map, not this time as a way to check or verify something, but also as a way to now add is collections of elements as values inside of our hash map. So when we talk about hash map, it's pretty much like a table where each one of their keys are unique, right? Or you have now identifiers to each one of those row on a table. So these two elements actually to me was one of the most quite interesting problems. Despite that it's been here as the array solution, because the idea here is something that we a lot of the time use this top K frequency. We use now is array and hash map, okay, as a way to now is count the number of elements that are most frequent given a particular sequence of numbers. So the idea here is that by counting each one of those elements in our hash map, okay, uh, and once we count all of those elements here in our table, in our record, then we now represent is an array of the same length of the input array, because this array will represent now is the number of occurrence that those numbers happen here. And I think that was something interesting and beautiful to look at. That is a way how you can make this connection across a particular data structure and another as a way to solve a problem. So in this particular array, what we did is just iterate through that array and if we already have now an index that match the number of occurrence in our hash, then what we're gonna do is to actually is append that number to that, because now this array, when we're starting from 0 until the end, the idea here is to get the most frequent element, which is the latest. Okay, we can get now is the latest elements until the k most frequent elements that we need. So in this particular solution, as we did here, we actually reverse the array for that. We, in fact, there is no need to actually reverse that. That's one of the solutions. Actually, it's not that efficient because we reverse that like so. But in our case, we don't need to reverse that. We just, in fact, want to generate is one of them where we want is to get is the k elements, which is the matches dot length minus k minus 1, and then matches, I think I put it, matches dot length minus 1, and I think it's going to complain about this. All right, so when we run this particular code this time, wait, what? Can you reload this? Okay, exactly. So as you can see, this time actually is quite much more efficient because we prevent some operation back there. And it say, hey, this is a wrong intuition. Expected -1, but we get is this. So I'm assuming that okay. Well, the idea here is that for this particular problem, okay, anyway, I'm gonna leave that as it was. So for this particular problem, right, our solution was not the best, was not the ideal. All right, but at least we started to develop this particular sense of what it's all about here, especially in software engineering, as a way to represent things and how we can use a representation that help us to solve a particular problems. And this is also part of the mathematical problem. So the other is the string encode and decode. This was interesting as a way to now encode some information that we need, that we later on, once we need to decode that, we're gonna go with and use that as a way to extract this data out of this. Similar for the product array Excel, except self valid Sudoku as a way to see how you can start into now using a representation, how you can now validate a Sudoku, not the solution, which is different, only the initial state of of a Sudoku, followed by the 3 by 3 matrix inside of each one of them. Because after all, this was 9 or 9 times 9 the matrix of this. For valid palindrome is also quite interesting because this can be solved as several particularly this can be solved with two particular problems. Whether is this is now actually is the this is now actually is the two-pointer solution, which is something that they actually have here. So we solve this is by using now is either the two-pointer solution. Why is this? Because at the end of the day, once we get this valid palindrome, or a palindrome is a phrase that when you compare each one of those characters, they are the same. So it reads the same forward and backwards. So this alphanumeric characters includes letters and number as well. So this was actually something quite interesting. We actually solved this in a previous submission here with let me see like that. So that was using now is the match regex regular expression as a way to identify that, hey, if this particular letter actually fills this, we're going to create is this sequence of palindrome here, right? And then we're gonna verify if that actually worked as expected. This solution actually use a little bit more of memory, but it's much more faster. Quite interesting than the two-pointer solution. Where now, even though that this is much less, is much more memory efficient, but in terms of runtime, it's actually take more time to do it. But in any case, and then we look now at the valid parentheses as a way to start to see how can we now is use a hash as a way to compare is things as a way to use this to compare elements, and then the stack as a way to now count or adding elements in a particular order. So where order here matters, all of this stack actually is something that we want to go with. So valid parentheses is one of the way of how you can do that. So the reflection here is that use geometry to solve problems, boxes, triangles, and that kind of thing. And the stack are useful for storing information in order, and hash can be used, as I mentioned, to count, group, and compare values as we iterate in a collection. This was now our first moment to see how can we use the two pointers, because at the end of the day, the two pointers problem solving technique is mainly used to solve is or when you need to find is pair of elements or triad of elements, right? So anytime you need to find pair of elements in a collections or a more than pair of element in a collection, in this case, for example, as a way to find then what is the two possible number that when you add up you actually have that. This problem was more focused on how you can use this now the problem solving technique called two pointers, whereas the first was as a way to how you can now use is hash and how you can use now hash arrays as a way to represent them into using arithmetic for that. So then we'll also look at this as a way to implement now a stack that was actually quite interesting. So the real challenge here was to see now the challenge here, or the value proposition of implementing this mean stack, is just as a way of how you can do that by reusing some other data structures, and how most of the time when you have a problem using another data structures and now using another data structures, a lot of the time it reduces the logic complexity, which is something that you really want to. It is something that you definitely want. So this is how we actually implement this, our stack, as well as our mean stack. Right? And as we move on here, well, how now we can actually start to compare that, and how a particular pattern is starting to arise as we move down here. So this was quite interesting as a way to implement that, similar to the best time to buy and sell stock, as well as the container with most water. All of this was a way to see how you can use now this two pointer and use that as a way to check a condition that you need to. All right. So that was interesting, very very interesting. But today we're gonna take a look now at this, which is check if a sentence is Pangram, then longest common prefix. But I don't think I'm gonna do that. In fact, I'm gonna is move on to the find all duplicate as it is, which is something that we're gonna handle that day 15. All right. Find all duplicate in an array. So I find all duplicate in an array. Why is that? Because this is what is relevant for us right now. Yeah, this is what is relevant for us right now. For our next coming, for our next coming interview. So let's get into this. Let's get into this. Let's get into this. Let's get into this. All right. So there are here. So a pangram is a sentence that is a sentence where every letter of the English alphabet appear at least once. So giving a string sentence containing only lower English letter. That's right. Return true if sentence is a pangram, or false otherwise. So because we have now 26 letters in the English alphabet, all right. What we can do is that if this string contains 26 elements, all right, and all of those elements are unique, then we can safely assume that yes, all right, you actually now this is a pangram. So this is our first solution, right? So we can say, hey, return this. I want to make sure that we actually is getting this sentence here, and as we see, if we're making some assumption here. So for example, this is part of the constraint. We're going to receive that as 1,000, a word of 1,000. And sentence consists on lowercase English letter. So if we need to actually consider uppercase, we will need to define is a little bit. So our algorithm will be a little bit of complicated. So, but for this case, all right, by using now a set, uh, where it will guarantee that as we move on, and I also want to actually uh, get into the MDN set docs here as it is. That's right. Okay. Give it to me in English. Yep. The set object lets you store unique values of any type whenever primitive values or object reference. I'm just more curious about is the initialization, the construction. Set like browser APIs. Browser set like objects or set like objects are web API interface that behave in many ways like a set. Wait, what? Just like set elements can be iterated in the same order, set like browser API. Oh, okay, okay, okay. For example, web IDL. Okay, font face set, highlight, custom state set. Okay. So the whole point of this is that see what the constructor actually is doing behind the scene. So since this receive is an iterable, which is optional, and an iterable object is an object that implement yeah and an object is that implement is the iterable protocol as they mention here. Okay, so this iteration protocol is something that is not new to the language. It's in fact is a design pattern that regardless the data structure, the underlying data structure, okay, array, set, stack, queue, linked list, double linked list, tree tries, graph. Regardless this data structure, you want now is a particularly inconvenient and consist way of how actually you're going to iterate through each one of those elements. All right. So this iterator protocol, which is something, this is part of the iterator protocol here. All right. This is a design pattern. This is now a behavioral pattern. Okay. Enter in the iterator protocol, but this is part of the behavioral patterns. It's like, hey, how can I now make as the image is pretty self-descriptive and it's self-explanatory, and that's interesting. That's very interesting. As I mentioned here, so regardless the way of the different type of data structure, we want a particularly way to actually now get that element, right? So we want a way to actually iterate through all of these elements in the most effective and efficient way possible. How so? By actually anytime we run this function, we're gonna get is that particular value. We run the function again, we got the next one. We hit that again, the next one, and so on until you get the last element. So this is made of two pieces. You got now the iterable protocol and the iterator protocol. So the iterable protocol is an object that indicates the underlying iterable logic, or which is something you can customize, which is going to describe the iteration behavior. Okay, the iterable protocol. So what values are going to be looped over, and because this is something that you can define with the iterable protocol, you can define is the iterable behavior. In the context of JavaScript, we use now is the for of as a way to now use the for with of to indicate that whatever element that we want to iterate is now it now hold the iteration protocol. Okay, which is, as I mentioned, it made of the iterable protocol, the iterative behavior, and the iterator protocol, which is now the way of how now these elements is going to uh, give this element. So the iterator protocol is this sequence of elements that is going to produce as value. So this it is implement using is the next object. So it return is an object that contain next, followed by other properties like returns and throw. Uh, so next inside of this function you have now is the two properties like done and value. So when now you run this function next, now you're going to get is the particular value at at that position at that moment. You might wonder is that how actually this is how now the language actually know how to keep track at which position it is in the data structure. Oh, that's when closures came here. And because closure is a way of how now the language remember things, okay? You can think of this is like a little backpack that is provide anytime you return a function from another function. And this backpack contain is now is the outer lexical scope. So this is a way of how now the language can provide you a convenient way to actually remember things or store things, right? There's also some caveat for that because now you have it require careful programming as a way to once that memory is not being used, you need to release that. So, in any case, that was a huge overview of using our set, okay? But the idea here is that you need to pass this an iterable. And in JavaScript, iterables, all right, are made of couple things. So iterables objects, okay, it can be now an array, the async iterator and async iterable protocol. It also do this. So here we got now is the built-in iterables. So for example, strings, array, type array. Most of the time we don't use that, but we should. Map and sets and segments, right? From the segment prototype segment are all built-in iterables because each of their prototype objects implements a symbol iterator method. In addition, the arguments object and some DOM collection type such as node list are also iterables. There is no object in the core JavaScript language that is a sync iterable. And so web APIs such as readable stream have the symbol async iterator method set by default. Okay. But for all of this is that now string, arrays, maps, and sets are all iterables. So this is built-in iterables. So that's great. What does it mean? That is that once we pass an iterable object, all of its elements will be added to the new set. So what is doing behind the scene is that I'm going to receive, or I'm going to pass now this string. The new set, what is doing behind the scene is to get each one of those characters and add it to the set. Okay? And once we do that, all right, is this one? So once you do that, this sentence must have is the length of 26. All right, which is once you do this, all right, the length, all right, the length of this, or in this case, the size of this must be equal to 26. And if it is, then this is a pangram. And as you can see, that's actually quite straightforward, right? Even though LeetCode is saying, hey, no, this is false. So when you submit this, okay, that actually was quite interesting. Yep, actually doesn't beat a lot of that. That's right. But as you can see, is this one. So because instead of actually iterating through all of this, all right, and add each one of those elements to our set, which is that's exactly what we did here. But all of this code is now being handled that for us, which is one of the convenient way, and the reason why it's so convenient here as well. You can see other solutions like that. For example, this, it used this, as well as this. I would like now to submit this again to see if that actually beat some of that. Yeah. And you can see it's actually a lot of the time actually beat that. If we take a look now at our submission here, the runtime sometimes is much faster, but it's actually using is sometimes it's more memory than the other. But this is now delegating that burden to the JavaScript. All right, so far so good. That was a very interesting problem, not that hard. Solution here. Yes, right. And this is implementing is sets, arrays, and set. All right, good. Then you can now find all duplicate in an array, like so, which is something that we're gonna do today as well. Find all duplicates. All right. So, giving an integer array num of length n where all the integers of nums. Okay, so giving an integer array num of length n where all the integer of sums are in the range of n1, okay, which is positive, and each integer appears once or twice, return an array of all the integers that appear twice. So we can actually think of very brute force solutions. One of them is to actually iterate through all of those elements. So we can so far think of two solutions, right? So one of them is the brute force, which is iterate through these elements twice. So for the first elements, we're going to iterate to all of the elements and the way to compare that. The same for that, the same for that, the same for that, the same for that, which is something that initially, as I started to become a software engineer, that's my mindset, right? As a way to think in that particular sequence. But as I develop now this particular sense, now I rarely rely on that way of thinking. But it's important to describe that as a way to mention that this is the first thought that come up out of your mind. The other is the solution for the big complexity of that is all square, which is not good. It's horrible. And the other is, well, we can now use a hash map, specifically use a hash set as a way to see if that elements appear in our set as we move through that. All right. If that happened, all right, then it's a success. The problem with that is, well, now our space and time complexity is, in fact, is a linear time. But because here we get now a particular algorithm here. So you must write an algorithm that runs in on time, uh, and only use and that use only constant auxiliary space, excluding the space needed to store the output. So we cannot rely on that particular solution. Okay. Uh, so here's when things started to become quite interesting here, because we are now getting some information here. All right. Where now all of our numbers inside of these nums, okay, are all integers of nums in the range of 1 to n, which means that we'll have then until the length of that number. All right. So, for example, if we have 1, 2, 3, 4, 5, and 6, okay, that'll be 1 to 6, or we can is now have all the elements like this. We can say is 2, 2, and 5, and 6, 6. Oh my God, no. And 3. Okay. So, because of this, and we cannot use is another data structure, and we're guaranteed that this is now a way of how we can actually is this is only positive numbers. So one way to actually know if we visit something here might be is to, for example, put a negative number here as it is. How so? Well, if for example we already visit this element, right? So we visit this element here. Okay, so if we visit this element here, and the also the another thing is that the time is used only constant auxiliary space, excluding the space needed to store the output. So we can now use this the space output for that, like so. Okay, so we can use this space output for that, which means each one of those particular slots, it will indicate now the duplicate values. Okay, so what does it mean? That is that as we iterate through this the first time, and then because our array can be now in the array output is something that you can, it's not excluded, so our array output is this one. So on each one of our index we want to store is now is the number that we store. So for example here, if we do this, we're gonna add that 2 to the position 2. All right, that might be one way to put it. Yeah, we're gonna get is the 2 as the position 2. All right. Yep. Yeah, the 2 as the position 2. All right. So yeah, if they do that, then 2 on the position 2. The idea here is that this array will represent is our numbers. Okay. And so how can we know that actually if we visit a number, okay, if that is in that particular space, Okay, we add that number as it is. Right? So it actually includes 0 because our array can, well, our array will need to start is from here. So if this is the first time that we're iterating through this element, I'm going to now add is the 2 in that particular index, right? However, if I now detect another element 2 at that particular index, I'm going to is change to a negative number. By doing that, I can now is determine that I actually have a that I actually have is a duplicate here, right? And because all of these elements, each integer appears once or twice, okay, return an array of all integers that appear twice. So what we care about is that this is now a negative number, okay? As we iterate through the other elements, 5, you say, hey, let's going to add now 5 to the 5th position, all right? Let's go to the 6th one. Hey, now this is the 6th one, and then we are adding that to the 6th position. Hey, is the 6 actually exist? Yes, it is. Now this will become is a value here negative, right? And if 3 exists, let's go to add that positive number. So what we end up happening here is that for this particularly use case, we want is to only return those negative numbers that where each one of those exactly we want to return is the negative numbers, and after and before that we want is to transform each one of those elements into a positive number. So this is actually is the approach that we can take here. So the idea here is to, well, iterate through each one of those elements, right? Implement now the array that'll be is the length of that, okay? Because we can use that, we can use is the output because it's excluding the space needed to store the output, which is great. And as a way to know how a number is duplicate, we can is store is it is negative values. Okay, so as we iterate through these first elements, we're gonna do is like, hey, do we have now? Hey, do we have 1 here? Do we have now 1 in the result? Okay, do we have now 1 in our result? No, added. Okay, in the position 1, do we have that added? No, added. All right. In the position 2, do we have now that element added? Or in this case, it'll be this. This is the example here. And I don't know why we have this. Okay, because it's this exactly. So it's in the first position. We got now is the number 2. It's in the second position. We have that number. We have any number. Is exists something? No. All right. Let's go to add that. If that exists, I want you to transform into a negative number as a way to know, hey, as a way to represent, hey, this is now a duplicate value here. So this is actually is the idea behind this. So we're going is to take a look at the nums here, and because we can now actually is create an array here where now the length here of this, you can say it's not, hey, new array dot fill with the nums dot length. Okay, all right, with the num of length, because we want is to fill that, we want to fill that array fill. Okay. All right. I change the element with within our range. Oh, because we don't want is to change the element, my friend. We want, in fact, is to create an element for that. New array of field with null, where now the length will be is equal to the nums dot length. So the question here is that, well, I want now is to populate, okay, new array, because it's this one. Exactly. But I want to create now several elements there, which is a star and end. Okay. Good. So this contain all the value, and I want to start from here to the, for example, 6, right? Then you got all of this array with null, but it doesn't do that. Okay. Makes sense. It's because the constructor actually. Okay, it can be an array of elements, or it can be the length of that. So in my case, it is doing something like this. It is, hey, I want you to now is do this. Okay. But I want to create now this 6 elements. I know, but you gotta fill it with that number. I want to fill this from 0 to 6. That's quite interesting, which is great. But I want is to create an array with more elements. Oh, Jesus. let's say do something like this. It's like, hey, this will be the length, and I want you to each one of those elements fill the value with this. That's right. All right. Good. 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 So that's exactly what we want to do here, which is the result, right? So this is the result. We want is to tell JavaScript, hey, please reserve a space in memory for me of the length of the number that we're receiving here, and fill each one of them with null values, okay? And when we need to iterate through the nums, I'll prefer to iterate now is using the let. Here, it's going to start from 0 until you reach to the array dot length. All right. And the after through, you evaluate the block code is to increment that index, right? All right. So at the first position, I'm gonna use this as our example here. As the first position is that, hey, do we have 4 in our result, right? So at that position, at the position of our the first position, okay, which is particularly is numbers, right? So do we have now 4 here, okay? Is the index 4 contain something there? So if the index at that position contain is something, all right? If it's not, which means that is null, all right, let me actually add at that position this particular number, which is the result. So at that position, okay, I want you to now is add the value here. All right, good. However, if doesn't exist, all right, if that exists, what I want you to do is to do this. Yeah, so what I want you to do is to do this. Okay. Is I want you now to transform that into a negative value. So I want you to transform that into a negative value, right? So replace that or update that with a negative value. So what happened here is that as we iterate through all of these elements, so in our result, we want is to first remove all of the elements, all of the empty elements, all right, by saying result dot filter, okay, and only get me those elements that are not empty, okay. Return me those elements that actually exist, okay. Return me those elements that actually exist as the first step here. That's right. As the first thing, hey, please return me all of these elements that exist. And then I want you to now is return a map, okay, where now or even though in our filter we can actually do that, right? We can say, hey, give me all of the elements that, but I prefer to do that, and then return me is now an array where each of their values, okay, return me is the array where each of the values are negative, which is a negative number. You can say if, I think math provides some built-in function like math negative here. Okay, well, anyways, where now the elements are greater than 0, right? So now that I get all of these elements negative, I want you to now transform, or say in this case, I can also say filter, get me all of these elements that are this, okay, that are greater than 0, which means that are negative, and then I want to transform each one of them. What in this case I want to return is now the elements here, like I want to return now is the absolute value of this, which is using the math API apps, please return me is the absolute value of this, and this is what we got to return after all, right? So this in theory is supposed to work. So that was quite interesting. It's a element here, of course. That's right. And it say this is num, exactly. And here it say this. Oh, in fact, oh, it's because I'm returning is the it's because I'm returning is the positive numbers, and in fact it's the negative numbers. And there you got it. Holy French toast, this one. And once you submit this, holy F, bro. Holy F. Holy moly, bro. Yeah, but this was our solution here. And we submit this again. Actually, it's not that fast. It's not the fastest, but actually is work pretty decent. But all right. I think it's because we are creating is now a map here. That's what happened. So with filter, we are now iterating through all of these elements, which is O1. And with map, we are creating is now a new array memory for that. That's one of the reasons is like, perhaps that doesn't work as expected. But we can leave that, and that'll be all for this video. Take care. Bye bye.